I just wish these had,
It's a circle.
I wish these had key strokes for the pen and stuff.
Is there a name for the distance between 0 to 180?
To 180? Nah, really, it would just be half the period. We just go from 0 to 360, or one. It's not necessarily always 0 to 360. It's one full rotation of the graph, okay? So it's not always going to be 360. So something like this, the period is not 360. On this one it is, all right? Here's a little...
180, maybe, with one half of theta, or...
well, we'll talk about it tomorrow, okay? I promise. Let's just talk, let's show you a general equation. Y equals, I think I'm going to write it right, Y, I don't have the book in front of me, but I think they use this. Depends what book you use. They use different letters for this kind of stuff, right? This book uses A and B. The A, now James used a word that A stands for, and that's called the amplitude. Amplitude. Now the amplitude is how high it is. It's how high it is from the center line. Look what the center line is. The center line is right here, okay? So what is the amplitude of this graph?
1.
It's 1, that's right. It's from the center, that's how tall it is. And it's the same on the bottom. It's symmetrical, isn't it?
-1.
It's the same on the top, the same on the bottom. Well, we're talking about the height. I think they might put absolute value here just to indicate we're not really talking about the negative. We're just talking about the length, okay, how tall it is or how far down it goes, okay? But that's from the center line. It's not from here to here, because from here to here would be 2, wouldn't it? The amplitude is from the center line up or the center line down. It's the absolute value, so we just take the positive version. Stephen, you had a question? Okay. So that's called the amplitude. So look at this one right here. We're going to talk about more of this tomorrow, but where do you think this would go up to? So go up to the 3. So instead of just going up to the 1, guess what it would do? It would go way up to the 3, so it would be a lot taller, wouldn't it? And it would go down to the 3 and then come up like this. So
Maybe, like, squeeze it.
yeah, we're going to talk about that right now. Watch this. We're going to do a little formula for period. All right. So in order to find the period of the function, okay, this is what you do. You take 360 and you divide it by the letter B. What's the letter B? It's whatever that number is right here. Do you see that?
What? Say it one more time.
It's the period is equal to 360 degrees divided by B. Now they put absolute value around this because you're just using positive, okay? We're not using negative values.
Oh, okay. So if
All right.
you had a half there, it would be 720.
So on this one, what is the B? Here's, watch this. Here's our formula for this equation that we have drawn right here. What is the amplitude to this equation right here?
1.
It's 1, so it goes up 1.
So
What's the
0 to
B?
1.
What's the B? It's 1, isn't it? Okay, so 360 divided by B, which is 1, is 360. So the period of this is 360, okay? What if it was a half? Then it would be 360 divided by a half, okay, the period, or times it by 2, so it would be 720. So watch. It wouldn't go one full rotation in 360 degrees. Basically, it would go a lot, it would stretch it out.
So the top
360 would only be halfway,
half,
wouldn't
and
it?
then the bottom half would go to 720.
That's right. The bottom half would go here to 720. Do you see that? So that's what those numbers are doing. We're going to deal with a little bit more of that tomorrow. That was just like a little bit of introduction for that, all right? Before the clock runs out, I'm going to clear all that stuff right there. And I just want to show you the cosine, all right, just so that we see both of them. I'm going to get rid of the sine. I'm going to show them to you both at the same time after I show you the cosine by itself. Let's click on, come on. There we go. There's the cosine. Now look at the difference of the cosine. Now, why is it here? Yeah, why is it here?
Starts at 1.
Because the cosine of 0 is 1, exactly. The cosine of 0 is 1. That's why it starts up here, okay? Let's go to the main points. Let's go to the quadrantal angles. At 90 degrees, what's the cosine at 90 degrees? If you go up to the top, remember that? If you go up to the top, the ordered pair is 0, 1, so the cosine is 0. So at 90 degrees, it's 0. Make sense? All of this, it's basically kind of like the old style XY charts, right? When you learn to graph stuff. It's basically what it is. At 90 degrees, you know, you put the function in. What's the cosine? Again, this is cosine. Let me just write that down. So this is y equals the cosine of theta. So, again, if you wanted to visualize this, you know, it's that, oops, sorry, that's 1, 0, right? And that's 0, 1. I'm not going to do all these, but you get the idea. At 180, right here, what's the cosine at 180? It's negative 1. Boom. It's right there. Negative 1, isn't it? Just where it's supposed to be. At 270, what's the cosine? It's 0. 0, negative 1, right? So, oh, goodness. That's all right. I'll just edit it. Should have told me earlier.
I was trying
Right?
to
Yeah. Oh, you gotta. Yeah, you gotta jump in. I don't care if you interrupt me if it's the time thing. All right. At 360, watch. At 360, right here again, the cosine is 1. It just starts that. It starts that all over again, doesn't it? All right.
So did it literally just shift the graph?
I'm glad you said that. Watch this. Let's get rid of this stuff right here. Let's go to the pointer tool, and let's now put the sine on at the same time as the cosine. All right. Now the sine is blue. Do you see up here? The sine is blue and the cosine is red, and they look like the same exact graph, except they just look shifted over, don't they? And we actually call that, we call it a phase shift. Exactly right. Now watch this. This is kind of cool with this program. This is awesome. I could take this thing right here, and it's at 1. I want to move it over until it's right on top of the sine graph. So move it over. Boom, right there. How far did I move it over? It was here, but now I moved it over what? 90 degrees. Okay, so basically the sine and cosine are kind of like the same graph, except they're separated by 90 degrees. They have a phase shift, we call it, of 90 degrees. Isn't that cool? Uh-oh. Which one do I want? I want the sine, right? No, I don't. I want the cosine. Let's see. I want the G, which is the cosine. There we go. And go back to this. I don't know. Is it? Yeah, there we go. We're back to where we started. All right? Does that make sense? Yes, sir.
So if you know what the sine, if you have like the sine of an angle, can you subtract out 90 degrees from that angle, take the sine of the new angle, and is it the cosine?
It is. Yes, it is. Yes. Yeah. And we'll talk about, and it has a lot to do with, remember I did that y equals x squared and then I subtracted. A lot of that same stuff is going to come into play with this. All right. So yeah, it'll be the same kind of deal. All right. That's kind of cool, isn't it?
Kinda.
Kind of. All right. Do we have any time? Yeah, we got a couple minutes. Let's just play around with this program a little bit. Let's use the mouse. It's a little easier. I think. Let's just get rid of that, okay? And watch, this is what we do. Like if I wanted to, let's do that one that I wrote in there. What was it? It was, it was 3 sine, right? Was it sine?
Yes.
I got to put,
1/2 theta.
yeah, let's see if I can do this right. 0.5. Hold on, watch. I got to put x and then I got to put this. Let me just see if it works. Again, I'm brand new to this program. I'm not sure if that's going to work or not. Figures. What did I do? Maybe I need to put a parentheses around this. Where's everybody going? Is lunch that important? No, I'm going to give homework tomorrow. Let's see if that works. Ah, there we go. Check it out.
Nice. What is that?
That is what we talked about earlier.
Sine of
Remember I
1/2
said
theta.
the amplitude was 3?
Oh.
Okay?
Yeah.
And the 1/2, look at it. See? There's the 720. See, it goes up like this, and it goes down like that, and that's exactly what we said it would look like. It's just kind of nice to just plug it in and not have to plot it, but you guys are going to have to do it by hand. All right? You're welcome. Now, you will, hey, tell you what, let me tell you a quick story. A kid that I taught at Newcastle, taught him from 9th grade to calculus, right? I only taught calculus 1 year. And we didn't do any graphing on computers or calculators or anything. Everything we did was graphed by hand. He went to University of Delaware in the engineering program. First calculus class, the teacher said no calculators whatsoever for anything, no graphing or anything. He said he was one of the only ones that knew how to graph by hand. He said that he would have people flock around him. One time it was like he was teaching a class on how to graph this stuff, and it said it was all stuff that he learned in high school.
Wow.
And he thanked me for it. So you're kind of, you're being a little sarcastic, but you may actually come back and thank me for that. You never know. All right? So that's kind of cool. All right. We'll see you. Go to lunch.
Michelle Osborne, please come to the office.
The recording thing?
Yeah.
I got it online.
Please report to Mrs. Swan.
Is the recording thing still recording? Oh, there it goes. Let's stop it. Okay, bye.